Hello, Year 10, and welcome to the next lesson in this series, which is designed to get you started on the NEA programming project as part of your GCSE in computer science. So, we're going to build on from what we looked at last lesson. And if you remember, what we looked at in our last topic really was the idea of computational thinking and how that was going to help us apply decomposition to your choice of project. And this was the definition that we explored last lesson for what computational thinking was, and it was about starting to chunk down and break down that problem that you had chosen so that you could think of a method of solving it. And that's what we're going to be focusing on this week. So a reminder that you should be approaching the project in a methodical and structured way, that we didn't want you, and I still don't want you to start to code, and even starting the design properly. Last week would have been too soon. You need to make sure that you're applying computational thinking. So we are focusing all about algorithmic design this week. Okay, so let's remember what an algorithm actually is. So it's a set of instructions that describes how to get something done. Algorithms can be designed using pseudocode, which is something we're going to talk about in this lesson, and flowcharts. They are written using statements and expressions. So you should be comfortable with what an algorithm is if you're a GCSE computing student. Yes, the programs that you write in Python make use of algorithms, but the concept of an algorithm is so much simpler. The process of doing anything and the steps involved in doing anything are an algorithm. So even if you're making a cake or a cup of tea, each step and instruction in that process is part of an algorithm. So we need to think about the use of algorithms in GCSE computing to approach your project. So let's just remind ourselves what the project instructions actually are from OCR. And I quote, teachers need to ensure that learners cover each part of the project: analysis, design, development, testing, and evaluation. Why am I showing you that? Well, I'm showing you that to point out to you that design is not the same as development, and it's not the same as analysis, but particularly it's not the same as development. What I mean here is that it's not writing a program. Designing and developing a program are two different things. So you should still not be considering using Python at this point. Though knowing some of you, you'll be itching just to start writing a program, and you won't really be interested in mapping out a design, but you need to be able to prove that you understand the concept of design. And it's also worth bearing in mind that a lot of these skills are going to come up in the Unit 2 exam, which is a written exam, but the idea of being able to write algorithms and stuff is covered extensively in that exam. It's really important that you do this section properly. So really, there are two design methodologies that you can use to represent an algorithm. And we're going to look at these properly in year 11 because they are covered in unit 2, as I've just said. Flowcharts and pseudocode. And what I'm not going to do is look at flowcharts. I don't want you to do your design work in flowcharts. I want you to do it in pseudocode. And one of the reasons I want you to do it in not so the reasons I don't want you to do it in flowcharts is because I actually think it's harder to do this work as a flowchart than it is as pseudocode. And also flowcharts can be a little bit restricting. And what OCR have said is that generally they feel that the better candidates are able to use pseudocode. So even though you need to know flowcharts, and we'll cover them and we'll do them in year 11, it's more important to me that you're familiar with and comfortable with pseudocode. Because if you can use pseudocode well in year 11 and you can use it if you get a programming question in the exam, you are likely to score more marks. So this really does tie in ever so closely with the exam that you're going to be doing at the end of next year. So we're going to focus on pseudocode. The other thing to bear in mind is that I do not want you to design your work in Python. I've just emphasized a couple of minutes earlier that you should not be doing this, treating the development the same as the design. And that means that what you can't submit as a design is a Python program, because that's not a design, that's a program. If you were an architect and you were creating a plan for a house, some blueprints or a diagram for a house, you wouldn't build the house. You would do the planning first, wouldn't you? Um, and it has to be the same for this. So even though what some of you might end up doing, because some students always do, is they find this difficult and they do a little bit of coding and then they reverse engineer. And if you have to do some of it that way, that's fine. So in other words, you might write a bit of programming, do a bit of programming just to get your head around kind of what you're doing, and then map it out properly as a design and submit the design bit. What I'm saying is, do not give me Python code, because that is not design. That's not acceptable for Python or a design. So just a few pointers about what pseudocode is and isn't. So pseudocode is not an actual programming language. Okay, that's the most important thing. So I'm not asking you to learn or understand a new language. It's a simple way of describing a set of instructions in a manner that resembles a programming language. So it's something that should be, if it's done well, it resembles a program or proper syntax, but it isn't an actual programming language. It does have its own syntax, some of which is very similar to programming languages. Now we're going to talk about that shortly, but about the syntax. But you will recognize elements of pseudocode in the way that I'm going to recommend that you use pseudocode. As I've said before, if you don't do it in this exact same way, it's fine. So what you can use, and I will share this document with you, is OCR's reference language for programming. And what that means is it's the language or the pseudocode kind of terms and key expressions and definitions that they have stipulated are the ones that they use. So let's just have a quick look at what they look. Okay, so this is the pseudocode document, and I've shared this with you on Google Classroom so you can see it. And what it does, you'll notice it gives you all the different types of programming constructs, and you'll notice these are all things that we've actually already done in class. So you've done, when I said we've done the programming that we need to, we have done. And it just gives you ideas of how you could represent different kind of programming ideas using their pseudocode. Okay, so we do not expect you to memorize this. And notice what OCR say here. It says learners are not expected to memorize the syntax of this pseudocode, and when asked may provide answers in any style, providing its meaning could be reasonably inferred by a competent programmer. So don't panic if you don't think you can remember this. Okay, so I will share this document with you, and it might help you to do this this way, but it isn't by any means compulsory. So you're going to be representing algorithms in some form of pseudocode, and what's worth remembering is that if you write a pseudocode program, it doesn't run, because you have to convert it into an actual programming language. So we're going to have a look at a couple of do's and don'ts, and then we're going to have a look at a couple of examples. So the do's and don'ts of pseudocode. Okay, so do use control structures. So control structures basically means we are expected you to use the same programming concepts that you would if you were actually programming in Python. So iteration and selection, structures of code that control what happens within a given set of lines or given section of a program. I do expect you to use the proper names for variables and for subroutines. So you know how to define variables, you know how to give a subroutine a name, and so you just keep following those rules. The names should represent the function, the name of a variable or a subroutine should represent the value, what it actually means, what the subroutine actually does. Indent as if you were coding. That's really, really important. So if you're using Python, you're used to indenting for if statements and for loops, and you need to keep going with that because first of all, it makes it much easier to read, and second of all, it's good practice. Keep it simple. The idea is you're writing something that's less complicated than the actual program, and keep it concise. There is no need for these to write like 1,000 lines of code to represent a relatively simple piece of a relatively simple problem. So the things not to do: don't think in a language. So what I mean by that is this is not Python. So don't think in Python. Don't write the code as Python. And in fact, what I'll be saying to you in year 11, after 2.5 years of trying to get you to program and think in Python, I then want you to forget about it so that you can write in pseudocode and start to think in pseudocode. Don't be too vague or too general. So even though we want it simple and concise, remember you need to be able to represent each step in an algorithm. So if I did an algorithm for a cup of tea that was get tea, boil kettle, drink tea, that's far too vague. I've left a lot of steps out there, and it doesn't really give an indication that I know how to make a cup of tea. So remember, that's what your pseudocode has to do. It has to give an indication that you understand how to solve the problem. Even if you aren't sure how to code it in terms of syntax, you understand logically what the problem is, and how to solve it. So those are your do's and your don'ts. So let's go back to and look at an example of some pseudocode, and hopefully you're looking at this having done a decomposition that looks a little bit like this. You should have broken down your program into chunks, uh, saying what you're going to do and not how. This is the how that we're going to do now. And you should have numbered each of these stages. And you're going to need to write some pseudocode for each one of these tasks, because each one of these is a little problem that needs to be solved. So what our first job is to write a bit of pseudocode to solve this particular problem, to log in. So as I've just said, you're going to need to write code for each section. I'm going to look at some of an example for this one, and then we're going to look at maybe something slightly more simple so you can see different ways of doing this. So here is, using OCR's reference language, here is some pseudocode example. And if you look at it, you think straight away, well, it's Python. It's not quite Python. Yeah, it looks like Python. It resembles an actual programming language, but it isn't. So we haven't got things like, because we've got things like capital letters here, which we wouldn't normally have. We haven't got apostrophes. File handling is slightly different, but you can hopefully see this is the full solution to this particular problem. I've started to write this block of code, and this is what it looks like so far. I've used proper variable name. I've indented, so I've got to indent twice because I've got a while loop here, and then I've got an if statement, so I've got to indent again at this point. And so each one of these is literally a step-by-step list of things that I would do in order to write the login code. So this is very much the how. So if you're looking at that and thinking that that's quite complicated, let's look at a slightly different example. Okay, here's one where I've not quite as closely stuck to that OCR reference language as we might have done. But the question you need to ask yourself is, do you still understand what this program is doing? Again, it's not a whole lot. It's the create an account part of the problem. And again, I've used some recognizable programming words and terminology, but it's quite look like Python, because again, it is Python. But again, remember what I've done is I've used proper variable names, I've indented, and this time I've capitalized my statements. You can do that if you wish to, doesn't matter. And that's another example of what a piece of pseudocode might look like. Docs here mean simply that this is an example and it's unfinished, and this will carry on in here. So that's a second example of what pseudocode might look like. So is there an easier version? Yes, there is. I mean, as we said, it's best to use OCR's format, but I really don't mind if you don't. The important thing here is to remember, as long as it's understandable and that you can give it to the programmer and they will understand it, then any method is fine. There's no one correct way of doing it. Okay, so if you're panicking at the thought of having to write pseudocode, you think it's too close to Python and you're not going to get a Python, don't worry about it. So here again is an even simpler version of pseudocode. It's to play the game Fizz. Maybe some of you have actually played that game. But again, look at the symbols, look at the way I've written it. It's divisible by 5. I've just written it more or less in English. So the idea would be, if you were to look at that as a programmer, can you work out what that program is doing? Turn that into code, even if you are unfamiliar with the game Fizz. If the answer to that question is yes, then that pseudocode has done exactly what it should have done, which is provide a clear algorithm to show how the problem would be solved. Okay, so that's pseudocode. So your work for this week is as follows. Okay, you must write some pseudocode, and at this point, I'm assuming that your analysis is finished, that you've looked at any APIs that I've put in there, and that you've done your decomposition. So at least 15 lines in total. I mean, in total, that's OCR stipulation. That's crazy because you'll need far more than 15 lines to write as much as you can. As I keep saying, do not create this in Python. Do not hand me in a printout of a Python program or a copy and paste of a Python program from your IDE into your design. You must be able to use pseudocode in some context for the exam, so this is a good chance, no pressure, yeah, to try and get it practiced. Remember, pseudocode is not an actual code. So this design is literally zero pressure because nothing has to work. It's impossible for pseudocode to work in the first place. And when it comes to actually writing a solution, we're not going to do that this year. We'll do that in year 11, and we'll spend some time on doing that in the classroom so that I can give you some of the programming reminders and programming help that you might need. So because you're not going to write working code, writing simple pseudocode should be something that you can do. Okay. And this is important. I need you to do one pseudocode algorithm per section of your decomposition diagram. So every single time you put like a number box in your diagram, each one of those needs an algorithm to show how you're going to finish it and how you're going to complete it and how that problem is going to be solved. Okay? And that is the end really of the instructions for this week's lesson. Now, this is going to take you, or it should take you, a little while to do. So I'm going to say it as 2 weeks work, not 1 week work, because you've got quite a few algorithms that you're going to need to write, and it's going to take you a little bit of time, I think, to get your head on how to use a pseudocode. So I won't post a new assignment next week. I want you to spend your time this week and your time next week making the pseudocode and the design as good as you possibly can. So good luck designing. If you have any questions, email or drop me a line on Classroom, and I'll speak to you soon. Take care and stay safe.